We believe and we know that light seems to travel in straight lines. So straight line path of light is called a ray of light. So what is ray of light? It's just the straight line path of light. Okay. So the straight line propagation of light helps us to explain the two phenomena of light called the reflection and the refraction. So in this session, we'll be discussing on the reflection part alone. Okay, let's see how far this goes. About the laws of the reflection of light. And here we are saying about the reflection of light. So reflection of light happens when light falls on a highly polished surface, just like how a ball bounces when it hits a wall. Just like that, when light falls on a highly polished surface, such as a mirror, it reflects most of the light that is falling on it. And the laws of reflection, the first law is angle of incidence, that is I is equal to R, that is angle of reflection. And the second one is the incident ray, the reflected ray, and the normal all lies on the same plane. Okay, the incident ray is a line that falls on the mirror, and normal to the mirror at the point of incidence is an imaginary line which is drawn perpendicular to the surface of the mirror. And the reflected ray, which actually follows the law I equals R. So if theta is the angle that is the angle which the incident ray makes with the normal, the same theta angle will be made with the normal and the reflected ray, and it will be reflected and the light ray will be reflected in that particular angle. So all these three rays, that is the incident ray, normal to the mirror at the point of incidence, and the reflected ray will lie in the same plane, and the angle of reflection and the angle of incidence are the same. These are the two laws, and these two laws will be applicable to all types of the reflecting surfaces, including the mirrors. Then the image formed by a plane mirror. The plane mirror is an example of a highly polished surface, right? So the image, that is the face mirror, like that. So that the image that are formed by a face mirror is virtual, it's erect, the size of the image and the size of the object are equal. The image is formed behind the mirror. For example, if you say stay 30 centimeter away from the mirror and see yourself, the image will be formed 30 centimeters behind the mirror, and the image will be laterally inverted. What is lateral inversion? See, if you show B to the mirror, how will the mirror show? B will be shown as D. This is lateral inversion. Okay. So virtual and the image, the qualities of the image that are formed by a plane mirror. First one, it's virtual, it's erect, the size of the image and the size of the object are equal. The image formed is far behind the mirror, just as the object is in front of it. Image is laterally inverted. Regarding spherical mirrors, the most common type of spherical mirrors are concave mirror and convex mirror. And we believe that the spherical mirrors can be considered as a part of the surface of the sphere, right? So such mirrors whose reflecting surfaces are spherical are called spherical mirrors. So in case of a concave mirror and a convex mirror, both are spherical mirrors, but the reflecting surface of a concave mirror is curved inwards, while this shaded portion is the hard surface. The reflecting surface faces towards the center of the sphere. So how we draw a sphere here, we will be drawing it towards your left. While the reflecting surface is curved outwards in the case of a convex mirror. So this is the reflecting surface here, and the shaded portion is the hard surface, and this sphere will be the reflecting surface is curved outwards. So how you draw the sphere, you will draw towards this side, the right hand side. And a few definitions you will have to know here. Okay, let me bring the concept here. Pole of a mirror means it is the geometrical center of a mirror. If it is, see, that is the right through the center of this aperture of the mirror. Aperture means this portion to this portion. This is the aperture. Yeah, okay, if you call this M and N, this will be the aperture. M and N is aperture. The exact center of this aperture or the geometrical center of this mirror is called the pole. So, this is what it is written here. It's and pole lies on the surface of the mirror. Study that very well. Pole surface on the surface of the mirror, both in case of the concave and the convex mirror. While the other points like C, the center of curvature, and the focal point, all these, the focus, all those are lying outside the surface of the mirror. So the center of curvature of a spherical mirror. The center, as I said, be it concave or convex mirror, the spherical mirror appears to belong to a sphere, okay, which has a center. And that center of that particular sphere is called the center of curvature. So that is represented as C. So that is when you draw a sphere, you often note the middle point as O. So in the case of the curvature means it is the aperture curve. Okay, that is the curvature. The curve uh, of that aperture, that is curvature. Okay, so the middle portion of the sphere, we often note it as O. But in this case, because it is the center of the curvature of this we are looking for the center of curvature. That is the curve. That is the center of that particular part of the aperture or the curve of the sphere is the represented as a C. Okay. In case of the reflecting surfaces of the mirror, in both the concave and the convex mirror, it is not on the surface of this mirror. It lies outside. So in concave, it will lie in front of the mirror, while in convex, it will lie behind the mirror. So radius of curvature is nothing but if when you draw the sphere, right? So you have the radius. The radius of the sphere is the radius of curvature. So here you locate everything based on the curvature. Curvature is nothing but the aperture of the mirror. Aperture is that total curve that belongs that belongs to the concave or the convex mirror. So the radius of curvature is nothing but the r. That is the radius of the sphere. Okay. Then the principal axis of the spherical mirror. Principal axis is that you draw a line from the pole. That's the middle of the geometrical center of the sphere of the mirror to the center of the curvature. That is, if you draw an imaginary line, that is called the principal axis. So the distance between C and P is that line that's connecting C and P will be the principal axis. Then focus of a concave mirror. Okay, yeah, we will be discussing both the focuses here. The focus of a concave mirror is that when the light rays are falling parallelly to the principal axis, after the reflection, they will converge to a point which is called the focus of a concave mirror. So here the light rays are all falling parallelly to the concave mirror. They will hit the concave mirror. They will follow the laws of reflection. That is when it will trace I is equal to R. That will be the that's how the reflecting ray will be. So if theta is the angle traced with the normal by the incident ray, theta will be the reflected ray also. So the parallel rays will converge at a point, and that point on the principal axis, and that is called the principal focus. While in the case of a convex mirror, the light rays that are parallel to this principal axis, what they will do, they will diverge from this point. They will get reflected without converging, so it will get all dispersed away, right? So but these deflecting rays tend to come, if you extend those deflecting rays, where they will all meet, they will meet in a point on the principal axis, and that point is the principal focus of a convex mirror. That is, this is the point which where the light rays appear to diverge from the principal focus in the case of a convex mirror. So the light rays will come parallelly. After the reflection, they appear to diverge from the point F, and that is the principal focus of a convex mirror. The focal length is the distance between the point F and the P. We just saw the points here. In concave mirror, it will be the point where the reflected rays will converge, and that AF, distance between F and P, is the focal length. In the convex mirror, again the distance between the pole and the focus is the focal length, and where the diverging happens from this point F, the diverging happens, and that is this length. This is represented as a focal length, and that is represented by the letter small f. And aperture, as I said, the diameter of the reflecting surface of the spherical mirror is the aperture. So the relation between focal length and radius of curvature. So the radius of his curvature is nothing but the radius of the sphere of which the concave mirror or convex mirror is a part of. So that radius of the sphere is called the radius of curvature, right? So if you often see, the focal length will be half of that radius. So the relation between focal length and radius of curvature is, it is twice the radius of curvature is twice the focal length. Okay. So if you look into the pictures, you have seen that the C and distance between C and P, F lies in the midway, right? So here also the same. The P and C, that is F, lies in the midway. So the small f, PF is small f. Though focal length F is twice the radius of curvature R is twice the focal length. Then we'll be representing the image formation using ray diagrams. So when you draw ray diagrams, you have to draw at least two lines. One line should be parallel to the principal axis. The other line, it is your choice. You can choose which one. You can either choose a line that will go through the principal focus, or you can choose a line that will go through the center of curvature, or you can choose a line that will, or choose a ray that will pass through the pole. Okay, but you should know what are the laws that will, or how these rays will get reflected. In the case of a concave mirror, we roll the convex mirror also. The ray which is parallel to the principal axis. So if in this case, you will see the ray that is parallel to the principal axis. So this ray is parallel to the principal axis. And after the reflection, it will pass through the focus. Likewise, even in the convex mirror, the ray parallel to the principal axis after reflection, it will appear to diverge from the principal focus. So here in concave mirror, the parallel ray will converge to the principal focus, while in the convex mirror, the parallel ray will appear to diverge from the principal focus. Okay, that is, the reflected ray will diverge from the principal focus. Okay. A ray which is passing through the principal focus, in the case of a concave mirror, after reflection will emerge parallel to the principal axis. Okay, but a ray which is passing or which is directed towards the focus of a principal focus of a convex mirror will also, after reflection will emerge parallel to the principal axis. See, this ray is directed to the principal, through the principal focus. It will hit here and it will emerge parallel to the principal axis. Likewise, a ray, here the ray is directed towards the principal focus of the convex mirror. After reflection, see how it goes. It will go parallelly to the principal axis. A ray which is passing through the center of curvature, after reflection, trace back the same, it goes through the same path. Okay, so this is the easiest of all. So the line that goes through the center of curvature, the ray that passes through the center of curvature, in the case of a concave mirror, be it convex mirror, it will trace back the same path. See, the arrow is towards the, this is the incident ray, the reflected ray is shown towards this direction. Okay, see, in the convex mirror, here is the focus, here is the center of curvature. The ray which is directed towards the center of curvature will trace back the same path. See, it is tracing back the same path. So this is the easiest of all when you draw a ray diagram. The NCERT textbook follows this. This is the easiest of all when you draw a ray diagram. Then a ray which is incident obliquely to the principal axis towards the pole. See, obliquely means what? It will go, it will fall in an angle to the principal that is to the pole. See, here is the pole. This is falling obliquely. That is, it is falling towards the pole in an angle. So what happens? It is reflected obliquely following the law of reflection. So the law of reflection says I is equal to R. Here, it is going to the pole. So the principal axis will be the normal, and it will trace back the same angle here towards the other side. So it is reflected obliquely. Likewise, in the convex mirror also, with the ray directed to the pole, it is reflected obliquely towards this side. Okay. And before discussing, we should know what is a real image and a virtual image. So real image is any image that can be caught on a screen. Okay, you can get that image on a screen. While image and that particular image will be inverted, the image will be in front of the mirror. So what are the qualities of a real image? They can be obtained on a screen. The image will be inverted and image is formed always in front of the mirror. While a virtual image, it cannot be obtained on a screen. The image will be erect and the image is formed behind the mirror. Okay, the virtual images are always erect and they will be behind the mirror. Okay, while real images are inverted, virtual images are erect. Okay, real images are formed in front of the mirror, virtual images are behind the mirror. Okay, image formed by a concave mirror. So here we'll be having 6 positions. Okay, when the object means object is from where the light ray is coming. Okay, so the object, when the object is at infinity, the object is at infinity, the object is beyond C, then so it goes like this. The object is at infinity. So from infinity, all the light rays will be parallel to the principal axis. Okay, at infinity, the light rays will come parallel to the principal axis. Always remember that. Okay, and when then we will discuss it like this. The object is at infinity, then beyond C, then between C and F, between F and P. Okay, so now the object is at infinity. So what happens when the object is at infinity? All the rays that will fall from the object are parallel to the principal axis. So they will converge to the principal focus. So what is where is the image formed? Image is formed at the focus. Okay. So the image is formed at the focus. It is in front. See, this is the reflecting surface of the mirror. So this is in front of the mirror. How much is the size? You can't even see the size, right? So it's just like a point. So it's a very small point sized real inverted image, and it is formed at the focus. When the object is at infinity, in the case of a concave mirror, the image is formed at focus. It is small, real, and inverted. The image is very small, okay? Point sized. object is beyond C. So C is what? The center of curvature. When the object is placed at a place which is beyond C, so I will advise you to follow this picture, as this is the NCRT, uh, NCRT textbook picture. So object is at, sorry, object is beyond C. Yeah. When the object is beyond center of curvature, what happens? The ray that is parallel to the principal, for every ray diagram, you should do two rays. One first ray will be parallel to the principal axis. The second ray, I suggest you choose the center, the ray that passes through the center of curvature. Only in one position it is not possible. That I'll come to the point, next point, topic. So here, the parallel ray, that is parallel ray that falls into to the concave mirror from the object. See, the parallel ray, it will follow the law of reflection. So here will be the normal. It will go the same I. It will trace here and the R. So it is the rays passing through the focus, and it will go. Then the next ray, here we are choosing the ray that is passing through the center of curvature. So what happens? The ray that passes through the center of curvature will trace back the same path. So see the arrow, the ray that goes through the center of curvature will trace the same path. See the arrow towards this. So what happens? At junction of these two rays is where the image is formed. So image is always formed from the principal axis. Always remember this. So the image is always formed from the principal axis. Where are the two rays meeting? So at the point here and this point, the two rays are meeting. So here the image will be formed. So the principal focus, principal axis, we put B prime, A prime. That is the image. Okay. I have also put one other for a reference. See, this ray is a parallel ray. It will go through the focus. This ray, it will touch the object and it will go to the pole. So what is the law? I is equal to R with the principal axis as a normal. So it will get reflected in an angle. So the two rays are meeting each other here. So the image is formed from the principal axis. So A prime, B prime will be this one. Okay, the image, see the qualities of the image. The image is real image. It is formed in front of the concave mirror. It's an inverted image and it is a small image. Okay, see the image. What are the qualities of this image? When the object is beyond C, the image is formed in between C and F. In front of the mirror, it's real and inverted and very small. Okay, remember like this. Whenever the object is beyond C, the image is always small. Okay, and the image is always in between this C and P. Beyond C, the image is always small and it is real, inverted, and it is in between C and P. When the image is at infinity, it forms at focus. When the image is beyond C, it will, image is formed between C and F. It is formed in front of the mirror. It is real, inverted, and very small. Now the object is at C. So at C, what happens? The object is standing at the center of curvature. So AB is the object. The first ray is parallel to the principal axis, goes and hit the concave mirror. It will go through where? The parallel ray will always go through the focus. So it will touch the focus and go. The second ray is, because the object is at C, we can't draw a line through the C, right? So how do you draw? Okay, you are choosing here in this picture, you're choosing a line that will go through the focus. So any light ray that will fall through the focus will hit the concave mirror and will be emerge. The reflected ray will be parallel to the principal axis. So this ray emerged parallel. So where are the two rays meeting? This ray is reflected here. This ray is reflected here. So the image is formed at C. See the image? Both the images are of the same size. Okay, I have also chosen this one. This one is where the parallel ray is there, and the next ray I chose it to be from going through P. So from the light ray that will go hit the pole will trace the angle of, follow the law of reflection and trace the R, and it is reflected obliquely with obliquely. The ray that is directed towards the pole will be reflected obliquely in the tracing the same angle. So, and these two lines can meet at the point, and this particular point, and here is the A prime, B prime. So, the object is, when the object is at C, the image is formed at C. The size is same as that of the object. The image size and the object size are the same. It is formed in front of the mirror, and it is real and inverted. See, real, inverted. You have to have this picture in mind. This is very, very important and has come in the board exams many times. When the object is placed at C in front, in the case of a concave mirror. So at C, the same images of same size, the images informed in front of the mirror, it's real and inverted. Now, so now the object is placed between the center of curvature and the focus. So what happens when the object is placed between the center of curvature and focus? The AB is the object. So the first ray we are drawing parallel ray. Parallel to the principal axis, it will go through the focus. And the next ray, you are drawing the ray through the center of curvature. So when you place the center of curvature, a ray which will touch A and go to the concave mirror, it will trace back the same path. So where are the two rays meeting? Here. So here is formed from the principal axis. You should draw the object. So B prime, A prime. So it is a word. It's a inverted image. So my time in Zoom is getting over. So the image is formed beyond C. Image is in front of the mirror. It's real, inverted, and enlarged. Whenever the object is coming towards the mirror, that is when from C to P, wherever you keep the image will be an enlarged image. Then what? It will be real and inverted. See, the image is bigger, real, inverted in front of the mirror. So this the second ray I have I'm showing it here from the pole. So through the pole directed, it will also go obliquely. So the image is formed at beyond C. So when the object is placed in between C and F, the image is formed beyond C. The image is formed in front of the mirror, real, inverted, and enlarged. So I'll wind up the Zoom session here.